Now we have to find the electric potential of a system of a number of point charges. So in the diagram we have considered 3 point charges Q1, Q2 and Q3 be placed at A, B and C, and we have denoted the distance of Q1 from Q2. So here we can say that R12 is the distance of Q1 from Q2. Similarly, and here what will be the direction of R12? It is the distance of Q1 from Q2, and R21 is the distance of this charge Q2 from Q1, and we can denote the distance of R21 in this direction. Similarly, distance of Q2 from Q3 is denoted in this direction, and R32 will have this type of direction. R13 will have this type of direction. R13 is the distance of Q1 from Q2, and R31 is the distance of Q3 from Q1. So we have denoted different directions, and here the electric potential energy of the point charge Q1 due to other two charges is denoted by U1 is equal to U12 plus U13. U12 is the charge where what we can write, where U12 and U13 are the potential energy of Q1 due to which charges? Due to Q2 and Q2 charges Q3. And now if we put the expression 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. R12 is the distance of Q1 from Q2. So this is what potential energy of Q1 due to this point charge Q2. Similarly, Q1 will have potential energy due to the other charge Q3. So that will have the expression 1 by 4 pi epsilon 0 Q1 Q3 divided by R13. So this is the total potential energy of the point charge Q1. Then we have to find the potential energy of other two charges. So if we move to the next page, then what we can write? Similarly, the electric potential energy of the charge Q2 is what? U2, which is U21 plus U23. And if we write down the expression of U2, so that is Q2 Q3 divided by distance R23 plus 1 by 4 pi epsilon 0 Q2 Q3, so it should be Q1 not Q3, Q2 Q1 divided by R21 and Q2 Q3 divided by R23. Again, the electric potential energy of the third charge Q3 is what? U31 plus U32. So which is 1 by 4 pi epsilon 0 Q3 Q1 divided by R31 plus 1 by 4 pi epsilon 0 product of two charges Q3 Q2 divided by R32. So now we have to find the total potential energy of the system of three charges is what? U1 plus U2 plus U3. So here we can write only sum of three energies, that should be U12 plus U23 plus U31, because we get 6 energies due to 6 energies of 3 charges, so we cannot add 6 energy. In this case we have to consider only 3 energies. Now it can be written in this way: half 2 U12 plus 2 U23 plus 2 U31 is equal to 1 by 2. In place of 2 U12, what we can write? U12 plus U21, because U12 is equal to U21. In place of 2 U23, we can write U23 plus U32. And in place of U31, 2 U31, what we can write? U31 plus U13. So 1 by 2. So here what we can write? U12 plus U13. Then U21 plus U23. Then U32, U31 plus U32. Now if we put the expression 1 by 2, 1 by 4 pi epsilon 0 is taken common. Then what we can write? Q1, Q2 divided by R12 plus Q1, Q3 divided by R13 plus Q2, Q1 divided by R21 plus Q2, Q3 divided by R23 plus Q3, Q1 divided by R31 plus Q3, Q2 divided by R32. If we move to the next page, then we are moving to the next page, and we have to erase this part. Erase this part. So after that line, what we can write? So if we see the last page, we got half 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 Q1 Q3 divided by R13 in this way. So finally we can express this energy. In terms of summation. Therefore, U is equal to 1 by 4 pi epsilon 0 is constant, double and first we have to write half, then 1 by 4 pi epsilon 0, summation, then Qi, Qj divided by Rij, and first summation should start from I to 3 in this case, second summation starts from 1 to 3 again in this case, and what we can mention, I not equal J. So this is what? Electric potential energy of a system of 3 charges. So for a system of n number of charges, U is equal to 1 by 2, 1 by 4 pi epsilon 0, summation Qi, Qj divided by Rij. I starts from 1 to n, not to 3, and J start from 1 to n. And here what we can write? I not equal J. So this is the expression of electric potential energy of a system of n number of charges. Here we can write electric potential energy. Electric potential energy of a system of n number of charges. And here what we can mention, When the potential energy of three charges is expressed, when the potential energy of n number of charges is expressed, comma, expressed in summation form, comma, each term gets counted twice. Each term gets counted twice. So this factor half, so the factor half is considered. Half is considered.